This is benzene. Now this is phenol. At second position, nitro group. At the fourth position, another nitro group. And at the sixth position, another nitro group. Now this is 2,4,6 trinitrophenol. That is 2,4,6 trinitrophenol, which is commonly referred to as picric acid. This is picric acid. 2,4,6. This is 1, 2, 3, 4, 5, 6. 2,4,6 trinitrophenol is known as picric acid. In this lesson, we are going to learn preparation of picric acid, chemical properties of picric acid, and finally, acidity comparison between phenol and picric acid. So, let us begin. Preparation of picric acid. Let us see preparation of picric acid from chlorobenzene. Chlorobenzene, in which chlorine is a kind of benzene ring activating group. That is, chlorine activates benzene ring through donation of its lone pair of electrons. When chlorobenzene is nitrated in presence of concentrated sulfuric acid, then chlorobenzene converts to this compound. At ortho position nitro group and at para position nitro group, because chlorine is a kind of benzene ring activating group. That is why at ortho and para positions, nitro group combines to form 2,4-dinitro-chlorobenzene. Now this compound is hydrolyzed in presence of sodium carbonate. Then this compound converts to this one. At ortho position nitro group, at para position nitro group, and the chlorine of chlorobenzene, 2,4-dinitro-chlorobenzene, this chlorine undergoes replacement by hydroxyl group. Now 2,4-dinitrophenol, this is obtained. Now this compound is again nitrated in presence of concentrated sulfuric acid. Then this is obtained. OH at ortho position nitro group, at para position nitro group, again at ortho position another nitro group. That is, picric acid is formed. 2,4,6 trinitrophenol. Picric acid is obtained from chlorobenzene. Through this reaction, picric acid can be prepared from chlorobenzene. This picric acid, which is light yellow crystalline solid, Its melting point is around 122 degrees Celsius. Picric acid is soluble in hot water and in alcohol, but this is insoluble in cold water. Picric acid. Solubility. Soluble in hot water and in alcohol, but insoluble in cold water. Again, picric acid is used as explosive. It is used to prepare ointment, Phenol, which is used as antiseptic for burn injuries. Now let's see chemical properties of picric acid. Chemical properties of picric acid. Picric acid 2,4,6 trinitrophenol. Picric acid produces carbon dioxide gas reacting with sodium bicarbonate, and water is formed as byproduct. Then picric acid converts to sodium picrate. Here, this is sodium picrate. Picric acid produces carbon dioxide reacting with sodium bicarbonate. It shows acidic nature of picric acid. Again, picric acid is treated with phosphorus pentachloride. Then hydroxyl group undergoes replacement by chlorine. Here, this is picryl chloride, which is treated with ammonia. Then picryl chloride converts to this compound. Here, chlorine undergoes replacement by amino group. This is formed when picric acid is treated with phosphorus pentachloride and then ammonia, which is known as a picramide. Now let's move on to the next point. Now the point is acidity comparison between phenol and picric acid. Let us see the matter. Benzene. Now this is phenol. Here this ring indicates movement of pi electrons, continuous movement of pi electrons. Because of the continuous movement of pi electrons, benzene ring, that is phenyl group, attains electron withdrawing nature. As a result, oxygen hydrogen bond undergoes a heterolytic fission, and finally phenoxide is formed and proton is formed. In this way, phenol undergoes acidic nature, but picric acid, phenol, here nitro group, at fourth position another nitro group, at sixth position nitro group. In case of picric acid, on one hand, phenyl group is a kind of electron withdrawing group that eases production of this proton. On the other hand, there are three nitro groups with electronegative oxygen atoms. Here two oxygen atoms, two oxygen atoms, two oxygen atoms. These nitro groups ultimately affect this oxygen hydrogen bond. This oxygen hydrogen bond undergoes heterolytic fission more easily than phenol. That is why from picric acid, proton is formed more easily because of the presence of three nitro group. That is why picric acid is almost 12 times more acidic than phenol. Picric acid 12 times more acidic than phenol. This is about acidity comparison between phenol and picric acid. If this lesson benefits you a bit, please subscribe to the channel. No more today. Thank you very much.